Now here the question is, find the equation of circle in complex form which touches the line iota z plus z bar plus 1 plus iota and 2 minus iota z equals 2 plus iota z bar and 2 plus iota z plus iota minus 2 z bar minus 4 iota. Now here the question is, find the equation of circle in complex form which touches this given line iota z plus z bar plus 1 plus iota equals 0, and for which these two lines, they are normals of the circle. Now we know that normals intersect at center of the circle. So what we'll do is, we'll solve these two equations, which are 2 minus iota z equals 2 plus iota z bar and 2 plus iota z plus iota minus 2 z bar minus 4 iota equals 0 to find center of the circle. From this first equation, we'll write z bar and it'll be 2 minus iota upon 2 plus iota z. Now we'll put it in the second equation. We can write 2 plus iota plus iota minus 2 into 2 minus iota upon 2 plus iota whole z, and it'll be equal to 4 iota. Now we'll solve it. We'll get 4 minus 1 plus 4 iota, and it'll be minus 4 minus 1 minus 4 iota upon 2 plus iota z, and it'll be equal to 4 iota. Now 4 and minus 1 will cancel. We'll get this as 8 iota, which is 2. So value of z will be 2 plus iota upon 2 or 1 plus iota by 2. So center of this circle, it will be at 1 plus iota by 2. Now once we have the center, we need to find its radius, and for that we'll first find equation of tangent. We can write this as iota x plus iota y plus x minus iota y plus 1 plus iota equals 0. So it will be iota x minus y plus x minus iota y plus 1 plus iota equals 0. Now we compare real and imaginary part. We can write this equation will be x minus y plus 1 equals 0. So equation of this tangent is x minus y plus 1 equals 0. Now we need to find its radius. Now radius is nothing but perpendicular distance from center to this tangent. Now center of this circle is at 1 comma 1 by 2. So it will be 1 minus 1 by 2 plus 1 upon root 2. So it will be 3 upon 2 root 2. Now once we have center and radius, we can write equation of this circle as mod of z minus 1 plus iota upon 2, and it will be equal to 3 upon 2 root 2, and that's your option C. Now here the question is, let A and B be sets defined by mod of z is less than or equal to 2. That means all the points on the circle whose center is at origin and radius is 2 units. So this A, it consists of all these points. Now B is 1 minus iota z plus 1 plus iota z bar. It is greater than or equal to 4. Now we can write this as 1 minus iota, and it is x plus iota y, and it is 1 plus iota, and x minus iota y, it is greater than or equal to 4. Now we can write this as x plus y minus iota x plus iota y, and here also it will be x plus y plus iota x minus iota y, it is greater than or equal to 4. So these two will cancel. So we'll get x plus y is greater than or equal to 2. Now this point is 2, 0 and this point is 0, 2. So if we draw this line is x plus y equals 2. Now we need the points where x plus y is greater than or equal to 2. Now if you put origin, we'll get 0 is greater than or equal to 2, which is false. That means it has all the points which lie on the right of this line. Now area common to both A and B is area of this segment. So area of this segment will be 1 by 4 into pi r square minus 1 by 2 into r square. Now r square is 4, so we'll get this is pi minus 2. So this area of region A intersection B will be pi minus 2 square unit. Now here the question is, let z be a complex number having the argument theta and satisfying the equality mod of z minus 3 iota equals 3. Then we need to find the value of cot theta minus 6 upon z. Now z lies on this circle with center at 3 iota and radius equals 3. So we'll draw this circle. Now this is 3 iota. Now it says its argument is theta. So we'll take this point on this circle and this point is z and its argument is theta. Now we know that this is 90, this is 6 units and this angle is theta. Now for this complex number z, if we find r, this r, it will be 6 sine theta. So we can write r as 6 sine theta. So once we have r and theta, we can write z as r, which is 6 sine theta into cos theta plus iota sine theta. Now we can rearrange it as 6 upon z and it will be equal to 1 upon sine theta into cos theta plus iota sine theta, and if we rationalize it, we can write this as cos theta minus iota sine theta upon sine theta, which is cot theta minus iota. Now if we rearrange it again, we can write cot theta minus 6 upon z and it will be equal to iota, and that's your option C. Now here the question is, if one of the vertices of the square circumscribing the circle mod of z minus 1 equals root 2 is 2 plus root 3 iota, then find the other vertices of this square. So we have this circle whose center is at 1, 0 and whose radius is root 2. That says there is a square which is inscribed in this circle. And one of the point is 2 plus root 3 iota. Now we need to find other vertices of this square. Now we know that the vertex which is opposite to this given vertex, it will have its midpoint at 1. So suppose this is z1. Now z1 plus 2 plus root 3 iota upon 2, it is 1. That means value of z1 will be minus root 3 iota. So this vertex will be minus root 3 iota. Now what about the other two vertices? This is z2. Now if we use rotation, we can write z2 minus 1 upon 2 plus root 3 iota minus 1. So it will be 1 plus root 3 iota, and it will be equal to e to the power iota plus or minus pi by 2. So it will be simply plus or minus iota. So we can write z2 minus 1 will be plus minus iota and then minus plus root 3. So other two vertices, they'll be 1 minus plus root 3 and plus or minus iota. So this is how we can write all the 4 vertices of this square. Now here the question is, if the complex number PW lies on a standard unit circle in an Argand plane and Z is aw plus b upon w minus c, then find the locus of Z and interpret it given that a, b, c are real numbers. Now we cross multiply, we can write wz minus cz, it is equal to aw plus b. So we can write w as cz plus b upon z minus a. Now it is given that this w lies on a standard unit circle, that means mod of w equals 1. So from here we can write mod of cz plus b upon z minus a, it is 1. Now if c is plus or minus 1, then locus of z, it's a straight line, and if c is unequal to plus or minus 1, then locus of z will be a circle.